Uh, just want to thank you for joining us for this webinar this morning or this afternoon or this evening, depending upon what part of the globe you're located. But on this webinar today, there's a couple different faces here. So I'm Mike Mitchell with Sennheiser, one of the technical application engineers here in the Americas. And then we have Dan Waltons on the webinar with us, joining us from QSYS. To talk through some important things regarding signal flow with deploying multiple ceiling microphones. So our goal today is that hopefully that you will walk away from this time with a better understanding on how to deploy multiple ceiling microphones or even just one within a conference space, and know everything you need to know from planning for the deployment all the way through designing and commissioning your system through the signal flow process. So let's get started here. I'm going to get over to my presentation here. All right, just so one thing to know about Sennheiser in the business communication division is we have a mission, and that is we want to be your first choice for advanced audio technology that makes collaboration and learning easier. And that's by offering products that are intuitive, agnostic, and that's one of the cool things is we are brand agnostic. So we have partnerships with QSYS and a lot of other brands out there that can really help you come up with some really good problem-solving solutions. And our products, we want them to be audibly better than anything else that you can find out there in the marketplace. So let's dive into the Team Connect ceiling solutions. We have two solutions that are available. You can see there on the right-hand side, the familiar Team Connect Ceiling 2. The TCC2 has been around for a while and has been kind of leading our portfolio in ceiling microphones up until this year. And then at ISE, we introduced the Team Connect Ceiling Medium, and that is for the mid-size meeting spaces. Both of these microphones incorporate our automatic dynamic beamforming technology. This beamforming technology is best in class because of its narrow beam and its ability to pick up any talker position within the room. And this tight beam also allows us to have some really nice tight exclusion zones to minimize any unwanted noise in the room. Some of the features and of that dynamic beamforming is you get maximum freedom of movement. We're not statically setting the coverage in the room and having to worry about people moving outside of that coverage. And so you can have universal room coverage. There's no need to create presets in a control system for different seating arrangements of the room. The microphone coverage is very flexible, and very minimal technical configuration is needed when deploying these microphones. All right, next slide here. So we offer within that beamforming technology, we have the one priority zone. It's great. It can be any size that you want it to be. It can be as large as you want it to be, or it can be as small as you want it to be. I've seen people use almost the entire coverage area in some applications for this, where they will just zero it in on a lecture at a podium. So very flexible with that priority zone. We also offer 5 exclusion zones. These exclusion zones you would use to exclude coverage if the beam is tracking towards a projector, as you can see there on the slide, mounted next to the TCC2 microphone, as well as any other areas of the room that you don't want the beam to track and cover. We've seen this used in conferencing applications where there'll be the snack bar there, and they don't want to pick up any side conversations that are going on there. So it's really nice to leverage an exclusion zone for that. Okay, so let's take a look now at the different ceiling microphones in depth. Here is the TCC2. It ships in black or white. That microphone has 28 condenser capsules in it. These are real capsules that are made by Sennheiser in Germany. And all of these capsules in both of the microphones they have a high QC process when they're picked for the microphones. They're all developed, they're all tested for sensitivity to make sure that that batch is all going to work in concert together within the microphone. Coverage for that microphone is around 850 square feet, or has a radius from the center of the microphone out 16 feet in coverage. You can mount this in different ways. We have a mounting frame for surface mounting it, a suspension kit, as well as the extension brackets for fitting it into the US size ceiling tile grid. Because we are a German company, this is sized for the European tiles, but with the US extension brackets that ship with the microphone, it fits really nice into that 24 by 24 ceiling tile. All right, connectivity on the back of the microphone. There is the PoE and control. And along with a Dante primary and secondary, we also offer an analog out. That analog out is handy for some of the older Cisco codec systems, as well as physical security systems who may want to leverage that audio within the room that's separate completely from the conferencing system. So a lot of flexibility there. When you connect up one of these microphones, it is a 2-cable connection. So you're going to have the PoE and control connection, as well as the Dante connection. And this is just kind of a representation of how you may deploy that microphone. It can be on the same switch on separate VLANs or all on the same VLAN. But just know that that is a separate connection for the PoE to power the microphone, and the control data is separate from that Dante connection. A little bit deeper look on the Dante side. So we have multiple channels that are coming out of it, but both of those channels represent the one dynamic beam that is tracking around the room. So it's just a single audio channel, but we have 2 different ones. The differences in that is with the TCC2, we have what's called the main out. That main out is the output that you would use if you're enabling voice lift within the room. It's also mirrors the analog out. Or if true voice lift is off, you can use this for the video conferencing. But we do have the far end out that is strictly video conferencing output, that if that true voice lift gets kicked on, that processing will not affect that conferencing output. And the reason why you would want that to be separate is when you turn on true voice lift, we do a frequency phase shift back and forth that minimizes feedback nodes from building within the room to give you maximum gain for those voice lift applications. Now, it's not some magic voodoo sauce that's happening there where it's feedback free. If you do your standard PAGNAG calculation, you're going to get around 6 to 8 more dB of gain off of that output. So it just leverages, it just gives you a little bit more control and helps you get that voice lifted above the background ambient noise of the room. Now, the far end reference for on the Dante receive side of the microphone, that is audio that would feed back into the microphone. This is mostly used if you're not using a DSP and you're using like a Dante virtual sound card environment with the microphone. When the audio comes back in, what that does is it temporarily stops the beam from moving and forces it into a downward position away from any ceiling speakers within the room. You can also leverage this if you're using a DSP that struggles on the AEC processing side and has a little bit more echo. You can also utilize this as well. But if you're using a DSP, most of the time that's not really needed. And one thing also to keep in mind is if you're using camera tracking, sometimes this can interfere with those camera tracking positions. So just kind of keep that in mind in systems that you're deploying with automatic camera preset recall. So TCCM. TCCM is the new kid on the street this year, and it's been really surprising on how well that this microphone sounds. I am blown away with the quality of the microphone and just how much features you have within this package. So it has 15 capsules compared to the 28 that's in the TCC2, but the coverage goes down on that, down to 425 square feet. or 11-foot radius from the center of the microphone. We do offer a couple different mounting options. There's two major kits that you buy for this. It is the flush mount, which mounts like a ceiling speaker. And then you see the housing kit, and that is for surface mounting the microphone or suspending it from the ceiling. One thing to note is on the flush mount kit you see there, we give you a couple little things with it. We give you the little plate that goes over the connections, and that is if you're in a jurisdiction area that wants everything in plenum rated conduit, we do have the ability to do that with this microphone. Also, the suspension kit is thrown in as well, and that is for some of those ceiling tile systems where you go up there to put the microphone in and you pull the tile open and you wonder how the ceiling is staying up. We are just giving you that for additional security in mounting that microphone. Connections in the back of the microphone are different from the TCC2. Here you see the network connections and the analog audio. We've kept that analog audio just because we have found that a lot of people still utilize that. So the connections on this for the network side, you see there on the right-hand side, the PoE and data and control and Dante in, and then we also have an out on the other side of the microphone, and that is the default mode that the microphone ships in, and that is just a switched output that carries the network in to the network out, and also provides PoE power. So your typical connection in a single room would look something like this, where you would have just a single cable going to the microphone, to the network switch, and then serving control to control cockpit software, and also to any control and audio DSP that you're using. But it doesn't stop there. You can add two more microphones off of this to add a PoE plus connection. So one microphone is just standard PoE, and then when you add two more to a total of three, it is a PoE connection. And just like the single cable that you saw on the last slide, it carries the Dante and control data all on that. And when you connect all these up, you're going to see the microphones individually within control cockpit and within Dante controller. So there is no leader follower to the microphones. They all are independent, and you process those and configure those all independently within the control cockpit and Dante controller. Now, if you want additional security, say you do have a project that you're working on where you need the separate control and a separate Dante network or a separate Dante VLAN, we do give you the ability to put this microphone into a split mode where the first port becomes your PoE and control data, and then the second port becomes your Dante connection, and that is just a single Dante primary connection. And that can be changed within our control cockpit software. Under the network tab, you can change the mode there, and also within Dante controller. Speaking of Dante controller or the Dante outputs, very similar to TCC2. Won't unpack this as much, but it does have the far end out and the local out. Just know that those are a little bit different because of the advanced Dante chips and chipset that we have within this microphone. The far end audio is your first audio output, and then the local out is your second output. Also within this microphone, that analog out can be assigned to either one of those outputs for the processing. So you can have it for the video conferencing or the local out. That's all switchable. With the TCC2, the local or main out is just fixed to that analog output. So let's take a look at how you would put these microphones into a conferencing room environment. We have what's called our Sennheiser Room Planner. This is a free browser-based tool that you can use for laying out multiple ceiling mics or just one ceiling mic within a room to see how that fits. So I'm going to switch over here to my browser. I have that pulled up, and we're going to just take a quick look on what that looks like for putting and designing a room. So you can come in here, you can launch it. Just know that if you're here in the Americas, it's going to launch into meters, and you're going to want to switch that over to feet unless you have come from a country where you understand meters or the metric system really well. So let's take a look here. I'm going to create a room. So let's go. That's that typical 50-foot wide meeting space. And let's go 30 feet deep because we want to make this a divisible space here. So now we have our space. We can come in here and we can drag in multiple things. So I can come in here and put maybe a TV monitor on each side of the room to for that divided space. That I can add tables and chairs. I can add people into the mix. I can add a presenter here if the room's combined. And then now I can come in here and drop in my ceiling microphones. And so for this one, because it's a larger space, we're going to drop in the TCC2 and see how that covers. So I'm going to drop one here in the center of this room. We'll add another one here to this room as well. As you can see, we have really good coverage within this room, except for we have a presenter here that's standing between the coverage of those that are kind of outside of the recommended coverage area of the room. Now, if you're doing just an audio only application, you could move these forward a little bit more and get them into the sweet spot and minimize the pickup in the back of the room. But if you really want solid coverage in this room and you're leveraging some camera preset recall in this environment, you may want to even consider adding a TCCM to the middle here to pick up the speaker and track that talker there in the front of the room, especially for doing voice lift in the system. This would be a nice design as well to cover that center area. So a lot of flexibility with the different offerings there for large rooms, and you can even model down to the smaller rooms within this. So, all right, so now that you have your room designed, let's look at a few things that are recommendations for where you place that microphone within the room. Yes, this picture here on the right-hand side is taken from a real project in the wild that we got called, and they were wondering why the microphone had a lot of noise coming out of it and couldn't quite figure it out. So we went out to help them do a little bit of investigation work on this and discovered that this microphone is actually within our minimum of 2 to 3 feet from the microphone. So here in the US, it's really easy. If you're putting a ceiling microphone into the ceiling, there should not be any air handlers or projectors in the adjacent tiles around the TCC2 microphone. One thing that's nice about this picture to note is some of these newer lighting fixtures that kind of hang down that are those pendant strips, as long as they have a good foot or so separation from the microphone performs really well, even when those are mounted below it. So the ideal height when installing these in a room, you want that microphone to be anywhere from 8 to 10 feet from the floor, talker level of the room. Also, the distance between the microphones and the outside coverage for the TCC2 is 16 feet. 11 feet for the TCCM. So just keep that in mind when you're using that room planner. You don't want to have those microphones be any closer to each other than if you're using a TCC2, you don't want them closer than 16 feet apart, or TCCM 11 feet apart, because you will have a lot of overlap in that coverage area. So one other thing to know with this is our recommended background noise for the room is 45 dB. And we recommend that level for maximum speech intelligibility within the room, because once you have a lot of noise coming into the system, there's no way of really fixing that within our control cockpit software or the DSP. We can make the best of it by some of our sensitivity profiles that we have within there. And some DSPs have denoising, but you're always going to have compromised signal to noise coming through that. And Dan's going to show us here in a few minutes what that looks like. So that's one thing to keep in mind, is how loud the room background is when deploying these ceiling microphones into a room with multiple microphones. So before I kick this over to Dan, I want to go over couple little basic things with audio processing. When you have multiple microphones within a room, we recommend AEC processing if you're using a DSP. We also recommend the gated automatic mixer. You never want to use a gain sharing mixer in a conferencing application, especially with ceiling microphones. I cannot stress this enough. We get several calls and we open up the DSP file and there is a gain sharing mixer in there. And yes, gain sharing mixers are great when you're using them in a live environment with a live PA system. It gives a more natural feel, but within a conferencing system, you don't want a gain sharing mixer. And so with us, we recommend that you do a nom of 1 on that gated automatic mixer. And the reason being, because of our dynamic beam technology within the microphone, it's going to track to the loudest talker in the room. So if you have a talker sitting in that overlap coverage that we saw there in the room planner, both beams are going to track to that talker. And what happens is if you have more than one microphone open, you're going to hear an elevated background noise come up and also possibly have some good old phase and acoustic cancellation just because of the time arrival differences to those microphones. So we recommend a nom of 1 that'll pick the loudest and the best audio coming into the system and only allow that one single microphone to work. And then, as I mentioned a little while ago, the far end reference, we recommend using that if your DSP is struggling to process the AEC. That doesn't happen very often with a lot of these modern signal processors, but just keep that in mind if you are struggling with the far end echo there. So at this time, I'm going to kick it over to Dan, who has joined us from QSC, and he's going to walk us through some of the best practices when it comes to signal processing within your DSP downline from the microphones into these larger spaces. I'm going to stop sharing my screen here.
Awesome. I think I even learned some stuff, Mike, too. So, it's funny in our business, we all tend to just, jump into something, not dive deep, just kind of do it on the surface. And so I really appreciate that. I'm already looking at some of our applications where I think I can make a couple extra tweaks and get things a little bit better as well, too. So, and that new microphone, awesome option there as well, too. So thank you, everybody. I appreciate everyone joining us today for this. Also, Mike, don't worry about the metric thing. In 1983, my 7th grade science teacher said, before I graduate from high school, the entire world will be using the metric system. So no problem there.
Yeah, we're good to go, right?
Yeah, we're good to go. So anyways, appreciate everybody. I'm going to just, what we're going to touch on today is I'm going to share my screen here and go through a slide deck. We do have a deep dive webinar series that we do. And what I did was, let's see. Oh, why did that change? Oh, I don't know what happened there. All right, you guys got my screen up there. So what I do have, so what we've gone through, we do these webinars, kind of like what Mike's doing here as well. So this is just a small portion of a full webinar we do that's an hour long. So just kind of, we're going to touch today on some best practices in gain structure and some things that we can do to best utilize our AEC and things like that. And obviously, this is a high level overview, but we'll have some key points that we want to talk about. So one of the first things, best proper gain structure, everybody should know, is a key component to getting the best audio performance out of your acoustic system. And one of the things I always like to start out at the beginning of these and talk about is, any kind of programming, whether it's DSP program or control program and all that, it's kind of like artwork, right? So, I'm going to tell you some best practices today, but, if you've got something that works and delivers a consistent result, by all means, that's there. We're not here to say a hard and fast, there's going to be some things that, hey, you really should try to focus this. And if what you're doing is not achieving the results you do, then maybe kind of step back and reevaluate that a little bit. So anyways, just kind of have a basic signal path up here on the display of kind of what we see and go from there. One of the most important things is we got to talk about a couple of definitions of language of audio before we get into any of this. So noise floor is the base noise that's associated around any electronic circuit that's being used, right? And then from there, we end up, when we talk about the noise floor, we're talking about what's at the very bottom, right? So, you know, if I have an open microphone, or if I just have an input, I'm going to have a certain amount of noise that just comes into that. And then at the very top, at the top of the dynamic range, what defines that is the point at which the signal clips. Now, in the analog audio world, we measure things in dBu. So and so what you end up here with, you know, if the noise floor was at -81 dBu, which I don't know any quiet microphones that are going to be that quiet, all the way up to 24 dBu, we have a greater than 105 dB dynamic range, and that's how we discuss. That's how we do that. Now, headroom is the distance between the nominal level which you set. So nominal level, you know, a lot of people say 0 dB, but it's actually +4 dBu in the professional audio industry is the nominal level. And the reason we choose that is that because it takes about a 10 dB increase in SPL to be perceived by our human ears as twice as loud, we want to be able to have 20 dB of headroom from the nominal level that we have to the clipping point to be able to feel the dynamics, you know, of speech or any audio that's coming through that. Signal to noise ratio is on the bottom half of that, right? So signal to noise ratio is from that nominal level that we've set, where is the noise floor in relationship to that? Now, you know, this graph is literally just showing an open input that doesn't have a mic on it or anything like that. You know, I think some of our input cards are rated at, you know, -81 dBu, nothing plugged into it. So it's going to be very rare that you see that, but we'll have some other examples here. So signal to noise ratio is, in fact, that difference between the nominal level we set and then the noise floor itself. And then the nominal is obviously that sweet spot. Now, the key element here that most people, we need to understand, though, is, you know, we put a preamplifier in there, you bring your input device in, and, you know, our input cards or any of our inputs, but any DSP is going to have an analog preamp before it goes into the digital world, before it goes to the analog to digital converter. The quality of the sample going into the A to D converter is one of the most important things. But we have to, in order to understand our QSYS gain structure and in general, you know, DSP gain structure, we have to explore the conversion into the digital domain. So in the QSYS platform, and this is a key thing, and some of our competitors don't have their input meters in dB full scale, but you'll notice here that this says 0 dB full scale is our clipping point. So once things go through the analog to digital converter, then we have a different unit of measuring in the digital world. In the digital world, 0 dB full scale is your clipping point. So I only say that because when I first came to work at QSC, I, you know, was pretty well versed in some of the other DSPs, and I'm used to setting all my inputs to 0 dB or somewhere around there, and I'm like, wow, I'm almost at clipping here. What's going on? So that's just one thing. If you're using the QSYS environment, know that our input meters are set to 0 dB full scale. So therefore, you should, instead of looking for somewhere around 0 or +4, you actually want to bring all of your signals, microphones, program audio, any of that in at -20 dB full scale. And so that would give you, you know, from there to 0 dB, from -20 to 0 is 20 dB of headroom. And then we calculate our noise floor after that. You want 20 dB. So you'll notice here, dB full scale is the meter. So after the signal comes in, goes through the analog processor, and then becomes digital, and then we have a digital meter there. So what you want to do is just add gain. The lucky thing is with the Dante mics, you're going to get a pretty decent signal level already, but you still want to make sure that that's there. Microphones do have their own noise floor, and it's based on the ambient noise of the room, right? So what you'll do is you'll add preamp gain to reach that -20 dB full scale. Do this for every input in the system. There's no way to fix poor signal to noise ratio at the mic with DSP. Mike was kind of talking about that. You know, we do have digital stuff in there, but we don't have magic. So the AEC algorithm inside of our processor and a lot of other people's has noise reduction in it, but bass intelligibility is still required for you to be able to work properly. And also the noise reduction in those AECs is really to just get rid of steady state noise. But like Mike was saying earlier, you know, if you've got that HVAC, you've got projector fan, sometimes there's, you know, loud Ethernet switches and racks that are in the room that'll do that. You know, so we can pull some of that steady state noise out. But if you got Bob, the loud talker that's in the office, you know, next to the conference room, that noise reduction isn't going to reduce the noise of Bob, the loud talker. So But the most crucial part of the signal chain is the integrity of the sample. So we want to make sure that we get, our inputs are looking properly. So if we look here at the talking about intelligibility and about the noise floor. So if I've just opened this mic up, I'm just quiet in the room, which for me is hard to do, and just listen. If I'm seeing upwards to negative 31 dB, right? So we're getting negative 20 on my dB full scale meter is where my nominal is at. I'm only 11 dB below that. I only have 11 dB of signal to noise ratio, and 15 is what's minimum signal to noise ratio. Remember, that's minimum, right? So if I come back here, and if that room is actually quiet enough that it's negative 42, right? So negative 20, I go down to negative 42. That's 22 dB of ability there that I've got for between my noise floor and there. So my signal to noise ratio. So that's the best way to do this. The way to test this is have a talker start walking in at a normal gain, adjust the gain up, and then, be quiet in the room and listen to that. But this is one of the most critical elements. If you're above that negative 35, if you're negative 35 and higher, we can't, there's nothing we can do magically in here to improve that speech intelligibility. That's where we have to just, follow the science. So, and then when we start introducing AEC into our system, obviously I wish every system was this basic, right? But the idea here is, you'll have a path to the far end and you have a path to the near end. So the far end is the people that are on the other end of the call. And so in this case, what you'll do is you'll bring, your microphones. This could be a software-based Dante block. This could be, Dante input, AES67, one of the cases. We're going to go run into an acoustic echo canceller and then go into a gating microphone mixer. So if this was that example, like large training space that Mike was talking about, we'd have our three inputs coming in here. We'd have each of those going into the acoustic echo canceller and then into a gating mic mixer. And then in a very simple system that would go directly out to the VoIP out. But obviously we know we might mix in, program audio, things like that as well. But we're just talking about the basics of this path. So then on the near end, what you would get is, we would get audio coming back in from VoIP. This could be USB. This could be analog audio coming into. So you're going to bring that audio signal from the far end back in. We're going to mix that down with any of the program audio or anything else in the room that needs to be going on. And we're going to send that out to our loudspeakers in the room. Now you'll notice that we have a reference tag here. So the reference tag, we're going to pull a reference and come back to the acoustic echo canceller and feed that. And you'll notice it's right before the audio leaves the processor. Like I said, this is a very basic design, and we do in the full webinar, we'll talk a little bit greater about how you can play where you should put your volume controls and where you put the reference in order of that. Some people will like to put, before they mix all the signals together to go out, they'll have individual volumes here for the program audio and for the far end audio that's coming in to the near end. And so if your volume controls are here, then the reference right out of that mixer would be great. If you decide to just do one volume control and you balance the program and the far end audio together properly, then your reference would be on the outside of that volume control. The idea is as you turn the program audio up and down, we want to raise that reference level going there. So let's talk about some conferencing terminology. So latency, that's what it takes to remove the AEC reference signal. So the way AEC works is it's listening to the room. When we give it that reference, we're saying this is what's coming out of the loudspeakers and should not be sent back to the far end, right? Microphones, while they have some intelligence to them, they have no way of discerning between humans talking and in the room and human voices that are coming out of the loudspeaker and reflections and all this other stuff. So we do need some look ahead time when we're doing AEC. In the QSYS world, our Core 110s, all of the smaller form factor have 21.4 milliseconds. Our larger cores do at 10.7 milliseconds. Now, this is a unique thing with QSYS, and I'm not going to dive super deep into it, but tail length. So tail length is the amount of time that the algorithm is going to listen to the room and then do its subtractive process, right, of removing the things that shouldn't be going to the far end. Now, by default, I think the industry standard when people say, they have AAC in there, it's right around 200 milliseconds. And in QSYS, when we sell you a processor and say it has X number of AEC channels, we're referencing 200 milliseconds. That's where the industry standard lies. But in the QSYS platform, we do have the ability to, if you have a highly reflective space, we can up that tail length to 300 milliseconds. We can also update it for really large and big reflective spaces up to 400 milliseconds. I know that no architect has ever designed an executive conference room with 3 glass walls, a marble table, and a concave hard deck ceiling over the top of there, and then expected it to sound like a perfect phone call into the ear, So this has actually won us some opportunities in there. But effectively what that tail length does is allows us to, the problem with that, one thing in our platform, if you use the higher tail length, it limits how many channels of AEC you have because we're using more DSP resources for that. But if we take a look, we kind of talked about the signal flow here. I always seem to get ahead of my there. But we have our local microphones in. We go through the echo canceller gating back out to the far end. We also may mix this in here and do a general mix there as well. And then the path going out as well. Program sources in your far end conversation. So microphone processing, what we typically will recommend on here, typically apply your equalization and things after the echo canceller. That's our best practice. And you'll see in here, we're essentially using a high pass, a low roll off some of the low end that doesn't need to be sent to there. Whoops, how did I go back a slide? Yeah. There you go. A parametric EQ and then a low pass filter here, and then maybe even a compressor, right? So we'll do all of that before we go in the gating mic mixer. Never put gates before the gating mic mix. Oh, there we go. Never put dynamic ahead of this. So you don't want compressors, limiters, things like that ahead of the AEC. If you have to and you need to put some type of EQ ahead of time, you could put a low pass or a high pass before the echo canceller if you have to, but best practice says do all of that processing. You want that echo canceller to hear as accurate of a sound of what's going on in the room. Most important factor in successful AEC is having the correct reference signal. So when there is no voice lift, the adage is what goes to the loudspeakers goes to the reference. So that'd be all far end program sources. Never put a mic signal in its own reference. When I was new to conferencing, I know that AEC would scramble my eggs and I would like, okay, I need this mic reference. So, but that's just one thing if you're new to conferencing, but it'll sound like someone's underwater, right? Because what's happening is that algorithm is fighting really hard to try to cancel that voice that's coming directly in there. So, because that's part of the reference and it says it shouldn't be having that in there. So if we take a quick look at conferencing setup, this is what our acoustic echo canceller looks like. Others are similar and have some similar different controls and things like that. But noise reduction and enable right here. So we were talking earlier about, this is where you can adjust the noise reduction in the room. It'll kind of help, in combination, I found that the systems I've commissioned with the TCC2, and I haven't done the new microphone yet, but a lot of their noise reduction helps eliminate that. If you set the mic up properly, using the noise reduction in here, you should have to use very little of it. Do know that I always tell people, just because the knob is there, you don't have to use it, right? In the any type of equalization or DSP world, whenever you're manipulating a signal, you're affecting the purity of that signal. So process the signal as little as possible. So, I wouldn't just say, well, it might get really noisy one day and turn the noise reduction all the way up. You're going to start losing some intelligence and it'll color the microphone. RMLR. So right here is the reference to microphone level ratio. So this is the easiest meter in the world. If it's in the middle and it's correct, it's going to be green and it's going to get yellow as it gets too low. It's going to get yellow as it gets too high, and it'll be red on both ends. So the idea on the target there is to target that around there. You want to get it right in that green area right in there. So that's when you know that you've got the proper amount of reference being sent back to. So that's where coming into, if you have volume controls, you want for the room, you want to make sure that they're prior to your building your reference, because you want to be able to up and down that reference a little bit. Hold the adaptive filter up top. If you happen to mute a mic prior to the echo canceller, you can set the adaptive filter to where it will, you just set the room to be quiet and then see what the input signal is setting it about. And then you can put there, what that does is it keeps it keeps the it minimizes the time it takes for the echo canceller to have to reconverge when you unmute that mic. So it kind of fakes it out a little bit there. That one is a little bit of magic. The residual echo suppression or nonlinear suppression, nonlinear processing is what some of the other folks call it. Increase this if you're getting some residual echo, right? But the more of this that you add, like by default, I believe this echo canceller comes out at 25%, but the more of that you add to your signal, you're going to start getting closer to a half duplex situation, right? So we want to have conferencing that's like a telephone call and not like we're on a walkie-talkie, right? So this is also where you want to test for a double talk condition here. If you have too much RES in there, what's going to happen is if there are other people talking on the call, and if one person's talking on the call and someone else comes into the call and talks, you're going to get the two of them kind of canceling each other out a little bit. So, oh my eye. So let's see what we got here.
They have a quick question here, if you
Sure.
don't mind.
No,
It
no
says,
problem.
how do you increase/control RMLR level?
Okay, let me grab back to my slide deck here. So the RMLR level, so this level is you would increase your reference gain right here. So if you had multiple channels of echo canceling, what I do is, say if I had, maybe we weren't using a ceiling microphone solution, or we had several of them around the room, or whatever the case is, every microphone picks a little different signal up. So what you do is you bring prior to coming into the echo canceller, you can raise the volume of your reference coming in until everyone is at least above the green. And then then you can use these to trim it back. I recommend setting all your reference gains on the AAC block at 0, and then pulling down or up slightly 3 to 6 dB as needed to kind of do that. But I would do it external to the AAC with the reference gain at 0. But if I have multiple mics come into that AAC block and I'm using a shared reference, I will tweak those out. So hopefully that's a good answer there. So what do we do if there is still, yeah, that was our last bit. Okay, what do we do if there's still significant echo? One of the things is make sure your signals aren't misrouted or looped. This can especially happen when you have video codecs. I remember, the hard video codecs, sometimes they have settings in them where the outputs function in different ways. So you might be bringing the far end audio and your local audio back in, and you're getting a horrible echo. And the other thing, what I'll do is I'll go and mute microphones and verify that it's echo and not direct coupling, right? So is it coming in through the mics, or is it something there? If the echo is still there, then I mute all the inputs until I identify where our misrouted source is. It's kind of the best way to go. What if there's still residual echo? Well, you recommend treatment. I'm sure most architects would be happy to accommodate a boardroom with some like an anechoic chamber here. So. But what you want to do if you still have residual echo is check your tail length. If it's at 100 milliseconds, which by the way, if you do set our DSP to 100 milliseconds, you do get more channels of AC. But like I said, that 100 milliseconds is going to be for a very well-treated room, not a lot of selectivity. But if it's at 100 milliseconds, you could go to 200. If it's at 200, like I said, don't just, oh, I've got echo, I'm going to up the tail length, because that doesn't fix everything. It's just for highly reflective rooms in big spaces, right? Where there's a lot of reflection going on. So on very large rooms, you may require that 300 to 400, but what you're going to really want to do is recommend methods to the customer to reduce some of the reflectivity of the room at all. We EQ in the output signal chain is typically for the loudspeakers and for the room. So there, you'll look at curves that are representative of the loudspeaker you're putting in, and then kind of make sure that they're as responsive, as flat as possible. And then you're going to EQ for the reflectivity of the room. User gains better at the input or the output of the mixer. That's just a matter of how your customer is going to use it, or how you plan to train them to use it. The one thing to remember is don't give the user enough control to ruin their own gain structure. So set reasonable upper and lower limits. So you'll see here 0 to 40 dB. So all of our gain blocks and cues, just like other platforms, you can set the min and max on those. I actually had one customer that was like, just set it +3 and -3 because they just need a knob to tweak. I'm like, okay, whatever, So limiting prevents the signal from going beyond a predetermined level. So if you're going to an output limit, and then a peak limiter block as well there. So So we just talk about some of our output limiting and limiters. Typically what I tell people are we use limiters on the outboard side to protect downstream equipment. And on the input side, we typically use compressors or AGC for signal there. So, but you can just see here, we recommend that when you use one of our limiters that it comes out of default at the gain calculation being at 0 dB. We recommend just dropping that about 3 dB because it does overshoot while it's trying to work a little bit. And what we're demonstrating here is, on the analog outputs, you'll notice that in the digital realm, we're still in dB full scale, but once we go through the digital back to analog converter, then we measure in dBu. So we want to be able to be pushing close to a 24 dBu output out of the signal for professional devices that are downstream. If you're using QSC amplifiers, the limiting is built in there. There's some benefit in that. If you're not going correctly to QSD amplifier, you're in the limit example, we saw clipping at 0 dB full scale as you expect. So we kind of want to keep into that. At 0 dB of digital gain, you would get a plus 24 dBu for professional downstream device. If we're using consumer stuff, that typically is looking for a -8 dBu signal. So what you would do is leave your full strength signal going on the output in dBFS. And then you would just you would use the output gain to lower that down. Basically, you want all the things coming out at the right level there. And then obviously, if you had to feed something that has a microphone only input in it, there are weird situations. We can bring our outputs down by 61 dB, as you see here. So we can get into that -40, -30 range as well. Output gain structure, the thing to remember here, right? Why, a lot of people, why can't I use just the consumer output? Professional line level, maximum output is 24 dBu. So if our noise floor, let's just say is 50, I've got 74 dBu of signal to noise ratio, -50, right? If I'm using consumer line level and I come down and I have a noise floor of 50, -50 dB, I'm only going to have about 40 dB, or let's see, -10. Yeah, I'm going to have about 40 dB of signal noise ratio. And if I get down microphone level, I've only got, a -40 dBu. So just know that your signal to noise ratio gets a lot smaller when you do that as well. So, but calibrate your inputs properly, then come in and do some EQ on your mics and touch those as need be on your mic signals. Through and adjust any dynamics, anything like that. Auto mixing, please don't place gates ahead of auto mixers. It's like paying your Visa with your MasterCard there. And then use the fewest gain controls as possible to get the job done. So on the output side, depending on what you have downstream, you may want to use different limiting components and then calibrate your outputs to there as well. So that's kind of what we've got there. Any other questions that kind of popped up while we were there? Let me stop sharing. There we go. All right, that's an hour-long webinar. That's and I trimmed a lot out, but still, there's a lot there. But hopefully, that's some good stuff to kind of touch on. Yeah. So.
Yeah, we'll just hang out here for a few more minutes if you have any questions.
One of the things, so on and you guys introduced at ISE that medium microphone. Is it available in shipping and all of that as well?
Shipping now. Yep.
Yeah, I'll probably talk to you, Mike, about, for those of you who don't know, we built a training and experience center down in Austin, Texas. We do some camera tracking demos down there as well. Our camera tracking demos come out of there. We use in both of our cameras, we do one that is in our training facility, one in our training room. So we show that kind of demo. We also have, then that's done with a TCC2 in that training room. And then we also have a conference room there that has a TCC2 in it as well. But you know what, Mike, we may talk about maybe putting in that conference room when we get our plug-in made for it and everything. The smaller form factor might be a good use case for that.
So we do have a couple of questions that have come in here.
Sure,
one
absolutely.
Is this content available at the QSC website? I'm assuming that they're wanting to know how to get more information on gain structure.
If you go to the QSC, if you go to, I believe, training.qsc.com, you can go in there and there's on demand. You can take this. This is part of our quantum series training. So our local application engineers do some of these trainings, can do them in person in your office, or you can do these quantum trainings yourself online and get CTS renewal credits and everything for that when you do that as well. So Actually, I could even, but let's see if we got some other questions.
Yeah, we've got another question here about TCCM and camera preset recall with QSYS. They're looking at some of the plugins that are available. So that is currently in development. The TCCM, one of the things we didn't cover in this webinar just because of the time that's available, is the TCCM has a new API protocol that we're using that's more secure than the TCC2. It is a REST API, and with that, it requires new plugins and new control for that. So you're going to see when you get a TCCM, a little bit different enrollment process. When you open up Control Cockpit, you'll claim the device, and you'll set a third-party API password there for the third-party systems to control it. So just trying to move ahead and keep current with some of the regulations with network security, and make sure that any installation that you put these microphones in, that the microphones are not vulnerable to any type of penetration, whether it's on the enterprise network or not.
Absolutely. I answered via text the answer about the 24D. So that's the max, right? So you're going to max your signal level. You're going to max your system out, and you want it to be, at the clipping point, and then you're going to back, obviously, then when you bring the gain previous to the output back to a normal level is where you're going to see that, is where you're going to be then at 24 dBU. So we get slide decks when you're done. Thanks for the great info. Yeah. We'll have some materials we can push back as well. I think, Mike, are you going to send a follow-up out with that? Yeah, so we'll have some of that. For those people that did ask real quick, I'll just do a quick screen share. So if you're not, if you go to training.qsc.com, it'll come up and say, do you want to go to QSYS or QSC? It's the same, choose QSYS, and then you go up here to on-demand training, and they're actually identical. The QSYS training here, pro audio training is there. This QSYS quantum training level 1, I recommend this for everyone. You do want to create a login in our learning center so that you can actually get renewal credits and all of that stuff. But here's best practices and gain structure. Here's AEC. So these are two separate ones you can do on your own. We touch on digital video, not just how we do digital video, but these are general knowledge topics. So VoIP, TOTS, networking, control, SIP telephony, some control troubleshooting. So yeah, those are all great resources that are there. Plus, you can also go into QSYS training, and you can scroll down here, and it goes into level 1, which is an online class, talks about level 2 and what it does. But there's this great down here, if you go down to the bottom, additional learning, there's quantum level 2, but there's also our quick start tutorials that talk about lots of different features in QSYS as well. So yeah, absolutely.
Yeah. I will share one more thing too as well from our side when it comes to training. Let me get to our website here. Share my screen. We have as well on our website, if you go to the business for the BizCom tab here on our website.
I'm not seeing you, Steve. All right.
Oh, you're not seeing
Mike,
the screen?
I'm not seeing your screen yet.
I got to hit share. So if you go to our website, Sennheiser.com, you're going to see different tabs up here at the top. And under the business communications tab here, you're going to see upcoming events. You can click on that there and see all upcoming seminars. So there's today's, and we have some upcoming seminars, as well as you can go down here and watch past ones as well. So a lot of good resources there from the Sennheiser side on all of our products as well. So I can spend hours on here. A lot of good information.
Yeah, that's great.
All right.
Well, I didn't even peruse the list, see if I recognize any, but our darn AV business is a very small circle. So I usually, pick a few people out there that I've worked with, or there's probably a few there that remember me and I don't remember them, but I am getting older. So
yeah.
Shoot.
All right. Well, with that, I don't see any other questions. Hope you all have a good rest of your day. Good rest of, especially here in the Americas, a good evening if you are over in Europe. So thanks again for joining us. And we look forward to seeing you on the next one. So,
all right, let's see. We got one question that came in. Oh, thanks, guys.
Thanks. All right.
Thank you.
Well, thanks everyone.
Everyone.
We will see you the next time.
All right.
All right.